Hello. This video is from GED Math. We're going to do 5 questions from the numbers operations section of the GED Math test. Now, number operations is mainly concerned with things like adding, subtracting, multiplying, dividing, that sort of thing. But today we're going to see 2 of our problems are going to deal with percents and proportions. So we'll highlight that when we get there. And also, in general, with all of these GED Math problems, we're going to focus on our word problem skills, how to organize our thinking and to tackle these problems effectively. All right, let's begin. I hope you follow along. So question number 1 here is about cameras, a shopping trip here. Jolie wants to buy a digital camera. She checks the price at 2 stores, Digital Earth and Interdeals. At Digital Earth, the camera costs $160 plus a shipping charge of $13.25, and now there's no sales tax at Digital Earth. At Interdeals, the camera costs $150.50 plus a 6% sales tax and $1.25 for shipping. So this one is definitely a touch more complicated. Remember, I said we'd be dealing with percents, but that will be fine. We've got our selections for the answers here along with the question. So how much less will Jolie pay for the camera if she buys it from Interdeals rather than from Digital Earth? Okay, so with all of these questions we need to be very careful with knowing exactly what we want to do. What's the key word here? It says how much less. How much less? That's what we're going to be worried about. Just like if we'd said how much more or find the difference, all of these are going to involve subtraction whenever we do that. So how much more, how much less, find the difference. You see any of those things, probably you're going to do subtraction. Probably. Probably. All right, very good chance you're going to do subtraction if you do that. All right. So we're going to find the difference. So basically, what we're going to do is we're going to find the price of the first thing and then subtract the price of the second thing, and that will get us the difference between the two, or like they said, how much less. So that's our basic plan of attack. We're going to keep that in mind for the rest of the way. So this is our plan of action. I know what I've got to do. I've got to find the cost of camera 1. And I've got to find the cost of camera 2, and only then will I subtract the 2. So that's our plan. Let's get started. The first one is lovely. I like this one. These guys have style here. We're just going to have the base price of $160 plus that shipping charge, and bam, we have our total cost, which my handwriting's not too great here, but we'll say it out loud too. Maybe I'll just type it. Yes, that sounds like a better plan. So we ended up with $173.25. Okay, so that one was easy. Lovely. Good job. We have that accomplished. Mission accomplished. All right, but what was the next part of our plan? Remember, we got the price of the first one. We can't get distracted. We've got to find the price of the second one. That second one, the original cost was $150.50 plus a 6% sales tax and $1.25 for shipping. Okay, so on this percent thing, how that's going to look is going to look like this. So when we say 6% tax, what we're adding is 6% of the 150.50. That's what we're going to do. So 6% of the 150.50 is what we need to find, and that will be the tax. So our 6% we're going to have to turn into the decimal 0.06. So 6%, that's like 6 cents. You can see the connection there. 6% becomes 6 cents, or 0.06, and that's what we're going to be using here. This is anytime you do a percent of, Like if I just want to know 10% of something, 20% of something, in this case 6% of something, I turn the percent to decimal. So it's percent to decimal. So I always do that. That's the first thing we do. And then we multiply. So 0.06 times the 150. Okay, and what does that get us? I don't want to do that one by hand. I don't feel like it. So let's try this on the calculator. 0.06 times $150.50. And we get $9.03. Okay. So instead of that 6% tax, I know that it's going to be $9.03. Okay. Let me move this over here. I didn't plan this out. Let's try that now. Okay. Excuse me while I move this around. Need to plan that better next time. Okay. So instead of our 6% tax, we found out that from the result of this, the tax was $9.03. So we're just going to plug that in here. And now all we've got to do is add these three numbers together, which we can do that easily enough. You can do it, whoa, the way, that 6 isn't supposed to be there. Sorry, I hope that didn't confuse anyone with me layering it like that. But okay, we're going to add these like so. Alright, nothing carries. Oh, isn't this exciting? Isn't this exciting? Alright, so that's what we have. We have 160.78. So good job, friends. We now know the cost of both cameras. Are we done, though? Ask yourself, are we done? What was I looking for? We're always going back to our plan. So we knew that we found the price of the first one and the price of the second one. Now our job is going to be to subtract the two. That was all part of the plan from the beginning. So when I do 173.25 minus 160.78, hopefully when I do that, we'll get something that we like and that we can use. Also notice I'm subtracting the big one minus the small one. That's for convenience mainly. Otherwise we'd be getting a negative answer, and no need to deal with that. So 173.25 minus 160.78 gets us 1247. Alright, and if all of that worked well, that will be one of our answers. Look at that, number 3. So we're going to bubble in number 3, or we're going to select number 3. Okay, so how do you feel? We did our first GED practice problem. That was pretty easy. We read the problem, focused in on exactly what the key issue was, this how much less. We made our plan. And then we just executed the plan. So step by step executed the plan. On the note on this percents, if you'd like to do more with percents, I recommend Khan Academy, good friend Khan Academy. So, when I say friend, I just happen to really like the site. So you could go here. This is a percent problem. These kind of things can help you quite a bit. You can just type a search for percent, and a number of things come up that could be helpful for you if you're struggling with percents. Anyway, on to the next one. So that was problem number 1. The next one's going to be a little easier, a little more straightforward, I think. Let's take a look. What do you think? I'm sorry if you can't read that very well. I'll read it for you. This table shows the pay rate and average number of hours for the employees at Downtown Computer Sales and Service. So we have the employee, we have Crowley, Jackson, Ross, Stockton, and Wong, a diverse group there. Their hourly wages, $8.65, $8.40, $9.75, $9.25, and $8.80. And their average hours worked per week is 35, 38, 32, 30, and 33. So the question is, on average, which employee earns the least money each week? Which one earns the least money each week? Now, we're not just going to look and see who worked at the lowest wage. We know that Jackson worked at the lowest wage. We also know that Stockton worked the fewest hours. But we're going to have to combine those two things in order to find which is which. So how do we calculate how much they earn each week? It's simply going to be their hourly wage, their wage times the hours. That's all we're going to do here. Pretty darn simple. So we're just going to do the hourly wage times the hours. That's the key idea, is that that's how you find how much money they make in a week, is you times their wage by the hours. So I've got those set up here. Let's go ahead and just compute those super fast on our calculator. So they made $302.75. Scoot that up a little bit. And then how much did they make? Do you have any intuitive guesses as to who might have made the least money here? So this person made $319.20. $319.20. And this person made 9.75 times 32. They made 312. That was kind of surprising. Did you see this person with the highest wage rate made less than the person with the lowest wage rate because of those 6 hours? Anyway, then this person made 9.25 times 30. So that's 277.5. Alright. And finally, our last friend here made $8.80 for 33 hours and made $290.4. $290.40. Okay, so which of these is the least? This one's kind of easy. If there was any difficulty, you'd make sure that you line them up to the decimal to make sure that you can spot which one is right, but these are all pretty simple. So this guy is our not so lucky winner. He is the lowest paid employee there. And you are Stockton. Stockton, you are the least paid employee there. Okay, so that we picked number 4. We'll move on to the next question. Hopefully this one will be just as simple. Oh, well, we might add one more layer here. So the Stockton Knitting Club makes children's Irish knit sweaters to sell at the Stockton Winter Crafts Fair every year. This table shows the number of sweaters that the club members will make this year in each of 3 sizes and the number of ounces of yarn needed to knit each sweater. Altogether, how many ounces of yarn does the club need to make the sweater for this year's fair? So they're making sweaters, and we want to know how much yarn are they going to need. So we're going to go shopping for yarn. How much do we need? Do they really sell it in ounces? Anyway, that's besides the point, but we're going to measure it in ounces for today. Either way. So we need 8 ounces of yarn for every size 4 sweater, and we need 2 dozen of those. We need 16 ounces for every size 10 sweater, and we need 3 dozen of those. We need 20 ounces of yarn for every size 18 sweater, and we need 1 dozen of those. Alright, so do you see where we're going with this? First off, let me just say we don't need those numbers at all. That's probably one of the first things we can do to kind of simplify the problems, is just don't even, let's not even see those numbers anymore. Those are just, we're going to use the names. We'll use them in name form here. but we don't care what size they are. All we care about is how many ounces we're going to have. Okay, the next thing that we're going to have to do is know how this whole dozen thing works over here. So if I said 3 dozen, that'd be 3 times 12, and that equals 36. Alright? Okay, we cool on the dozen thing? So 3 dozen would be 36. 2 dozen would be 24. And 1 dozen would be just your basic dozen. 1 dozen is 12. Okay, so I've set up our math here. Let's figure out how much yarn we need for each of those. So in the size 4s, we had 2 dozens. 2 dozens, so 24, and each of those needed 8 ounces, so we times by 8 to get that there's 192 ounces worth of yarn. For that was 192, not 292, 192. Thank you. So then we're going to do this next one. So in the tens, we had 3 dozen, and each one used 16. 16 is it? And so that should take 576, quite a bit more for the tens. And also this last one, so we've got 1 dozen, or just 12, times 20. Excellent, 240. So what do we do with all this? Let's go back to the question, make sure we're on the right track. So the question says, how many ounces altogether, how many ounces of yarn does the club need to make the sweaters for this year's fair? So what do you think we're going to do there? How do you think? I know how much we need for the 4s. I know how much we need for the 10s. I know how much we need for the 18s. How about we add those? Okay. So let's add those up, and that will get us our answer. 192 plus 576 plus 240, and we get 1,008 as my answer there. Hope I didn't mess up anywhere. You guys will let me know if I made a mistake anywhere, right? All right. I hope you will. Let's move on to the next one. Good job on that one. This next one is just straight up order of operations problem. Just very straightforward order of operations. In case you don't remember, if you're a little fuzzy on the order of operations, I know we all get that way after a while. It's just sort of the rules of the road for solving a math problem. It's important rules to have. If most of you are familiar with driving, how if we go to like a 4-way stop, you have to decide who goes first. Right? You've probably been there. It's that sort of question here. I've got all of these numbers and all of these sort of operations. I've got subtraction, I've got multiplication, I've got addition, and I've got this multiplication here. I've got all of this stuff going on, and we have to figure out which goes first. So we have a priority system, and we call it the order of operations. Let me see. Let me go ahead and write that up here in blue. We're doing the order of operations. Okay, so we're doing the order of operations, and our kind of phrase to help us that is PEMDAS. We're going to do the parentheses first. Parentheses always come first. Then, so do you see this parentheses? We're going to do everything inside that parentheses first. Then we're going to do any exponents. Those would be the little numbers up above and to the right of other numbers. We do any exponents that come next. There are no exponents on this one, so we don't have to worry about that for this one. Then we're going to do all of our multiplication and division. So we have our multiplication and division. We're going to do that from left to right. Notice the way I put these are on the same level, so they're equal to each other. If I've got a multiplication and a division going on, or 2 multiplication or 2 division, how I decide which one comes first is by going left to right. Let me write that in here as well. Left to right. Same thing for the next guys, so I'll go ahead and write it twice. We're going to be doing our addition and subtraction also from left to right. Okay, so that's basic order of operations. So let's just go ahead and show you how to work through this. So when I'm doing an order of operations problem, I'm thinking very methodically. I just kind of think of this as my little checklist. I think, or do I have a parentheses? Do I have parentheses in existence? Okay, then I'm going to have to be worried about this. Let's use a green pen for this one. So this would be my parentheses right here. So I need to do everything inside the parentheses before I can move on. Now inside of the parentheses, so I'm still in this step. I kind of have sub-steps though, and then I'm going to have to decide between this subtraction and this multiplication while I'm within this parentheses step. So just like any other time, this multiplication and division comes before the adding and subtracting as I go down my order of operations. So this means I have to do this first, 3.3 times 0.5. Let's just call that 1.65. I guess I should go ahead and actually do that. We had 3.3 times 0.5 got us 1.65. Lovely. So that was their first step. All right. Then we have a 4.1. So within this, so I'm just bring it down. Sorry about the handwriting, but I'm just bringing this down. So the 4.1, forget the 0, 4.1 minus 1.65, and that's the next thing I need to do. I'm still laser focused on that. I don't care about anything else in the whole world. I can't even see it. I'm just focused on this right here, 4.1 minus 1.65. Okay, so inside of that we got 2.45. Let's go ahead and reassemble our question. We had 2.45, or how about we do this way? I've got 9.2, 2.45. I'll leave it in the parentheses. You'll see why in a second. Plus 1.2. So that's our new problem. So what does this mean here? What does this mean here? I've got, do you see this parentheses, I'm keeping it here for this purpose because this parentheses is going to tell us to multiply. That's what this parentheses means, is that we're going to multiply. So all I've got left in this problem is this multiplication and this addition. So let's go ahead and reiterate that. We've checked off our parentheses. We're done. We did everything inside of the parentheses. We just got this one number sitting in there. So that's fine. There's nothing to see here. Move along. Nothing to see here. Move along. Now I'm going to do my multiplication and division on our handy checklist. So always go back to our handy checklist. So I'm just going to multiply those two things together, because as I'm going from left to right on the multiplication step, those are the first two things I saw. So 9.2 times 2.45 equals 22.54. And then we have that sticking on here too. Do you see how this guy, he's just kind of been tossed, he's just been, I don't know, what do you call that? He's just been kind of hanging around this whole time, this 1.2. He's just shuffling them along, shuffling them along. Okay, well now it's your time. It's your time now, 1.2. We get to mess with you now. We have 22.54. Now, we've already done everything else. We've done our parentheses, we've done our exponents, we've multiplied it and divided. Now we're going to add and subtract. So we're going to start from the left-hand side of the problem, do any addition and subtraction that we see as we go from left to right. So I mean, obviously it's that one there. So 22.54 plus 1.2 gets 23.74 and the win. 23.74. Actually, I feel like bubbling this guy in, so let's bubble this guy in. Let's bubble in 23. My bubbling. 0.74. Wonderful. Wonderful, marvelous. All right, so 4 problems and 1 to go. 1 to go, but it's a good one. So number 5 here. So we're going to be our friend with proportions. So let's read together. Susanna is painting a mural in the foyer of City Hall. She is working from her original drawing and enlarging the drawing proportionally. In her original drawing, a tree is 9 3/4 inches tall. In the mural, the tree will be 6.5 feet tall. Okay, so we've got her original drawing, smaller, where the tree is 9 3/4 inches. In the mural, the tree is going to be 6.5 foot tall, considerably larger. So if a house in the mural will be 4 feet tall, how many inches does the house measure in her original drawing? Okay, now I'm going to show you, she is an artist, Susanna. I'm going to show you a bit of my artwork to explain this one. So this is basically what we have going on here. We've got, this is our scenario. So we've got the little drawing that we're basing our drawings off of, and then there's going to be the real deal that we're going to put on the wall at City Hall, and it's larger, but it's supposed to be to scale if my art skills had leveled up more. But anyway, so this is what you can kind of get the idea from this. So I've got on the small one and then over to the big one. And our question was, okay, so if this house is 4 feet over here, how much should it be over here? We can go ahead and check our intuition. Maybe you don't know how to do the math yet, but if this were like a multiple choice answer, could we take any answers that were above 9 3/4 inches? No, we couldn't, because do you see in the painting here, the house is less than the tree. Do you see the house is smaller than the tree? So the house has to be smaller than the tree here. So our answer has to be less than 9 3/4 inches. Alright, less than 9 3/4 inches. You could also be clever and figure out that this is somewhere around 2/3 as big. You could do that sort of thinking as well, but we don't need to try that. We have ratios to the rescue. Let me go ahead and tidy this up real quick. We're going to turn this 9 3/4. Think if I had $9 and 3/4, I would call that $9.75. And if I had $6.50, it would be 6.5. Okay, I like looking at that a lot better. So $6.50, or I don't really need that 0. Also, let me show you with those fractions. We could do it this way, so that 3/4 is 3 divided by 4 is 0.75. Cool beans. And then just tack on the 9, yada yada. So then the same thing with the half. 1 divided by 2 is 0.5, and just tack on that 6 for 6.5. Sweet. So now we can look at decimals. We don't need to look at, oh, how'd that go? Sorry. We don't need to worry about these fractions anymore. So what's the deal here? Let's go ahead and use the wonderful power of proportions. Let me show you how that'll work. We'll just work through this example. We're probably going to have to practice with some more of these to get it all the way if you're brand new to this. But if you're not, you're probably more than ready for me to move on. So what we're going to do here is we're going to see the relationship. So if something's 6.5 feet in the original drawing, I don't want to do this. Let's say if this is 9 3/4 or 9.75 in the original, 9.75 in the original is to 6.5 in the mural. as 4 feet, or as what in the original is to 4 feet in the mural. Okay, so I might have made that seem more complicated how I set this up than it really needs to be. The idea when we're doing this is that these two numbers, the numbers that I put in a fraction together as in a little ratio here together, you can think of this as a fraction or a ratio, I don't care. But the numbers that we put here need to have a relationship together. Like in this case, they're both the tree. Tree here, tree there. Or this was both the houses. And then they're equal to each other in that they're in proportion. The 9.75 is related to the 6, just as this number here will end up being related to the 4. Notice that I'm not worrying about the fact that this is inches and feet, because I'm going to be dealing with feet here in my answer. It actually all balances out. It's kind of nifty. We're not going to get into that too much. Feel free to ask later about that, or maybe we could talk about that in another video or something if you're wondering exactly how that worked. But we're not going to worry about it. We're just going to solve this proportion as we solve every proportion. Our favorite thing to do with proportions is you always multiply diagonally. So these guys we will multiply. So we're going to multiply diagonally. Oh, I lost my calculator. Alright, there we go. So 9.75 times 4 is 39. So we got 39 there, and then we divide by the number on the outside. So 9.75 times 4, we multiplied the diagonal numbers, and we're going to divide by this other guy, 6.5. So that's how a basic proportion we could solve. Divided by 6.5. Cool. So I get 6. 6 is the answer that I got there. Sweet. Also, let me know if you want to know more about this specifically. Again, Khan Academy. This is proportions 1. If you could just type in proportions up here, and you can find it. Alright, some videos on proportions, quite a bit of stuff on proportions. Alright, so I'm sure he can take care of you with more of the details. But as far as this problem went, we had the mural here to the original drawing. Sometimes you'll see these kind of problems with shadows. Sometimes you'll see this kind of problem with, shadows. I'm trying to think what else, but fairly standard kind of problem to see in GED material. And, oh, there's our answer. Okay, so let's go ahead and, I guess I should finish up. So we found out this house should be 6 inches tall. So let's go ahead and check that with our kind of gut feelings here. Does that seem like it could work? Because if it doesn't, we might have to redo it. But 6 inches to 9 3/4 inches when this is 4 to 6.5. I don't know, I think that looks pretty legit. It definitely fits what we were wanting from the beginning, that our answer had to be smaller. So I like it. Let's keep it. Anyway, good job, guys. I'm hoping you're able to give me any feedback. Feedback would be great. Let me know if these kind of videos are helpful, or you can request anything that might be more helpful for you. But anyway, good luck as you are studying and getting ready to take that GED test. Take care.